What if I told you we're on the brink of a new era? An era where we could design life-saving drugs overnight, predict financial markets with stunning accuracy, and maybe, just maybe, tackle something as massive as climate change. This isn't some far-off science fiction dream. This is the very real promise of quantum AI, a technology that is gearing up to change, well, pretty much everything.
So let's start with a really big question, right? What if a computer could solve problems that aren't just difficult, but are actually truly impossible for even the biggest supercomputers we have today? I mean, problems that are fundamentally off limits. That is the whole point of quantum AI. We're not talking about making our current AI just a little bit faster. This is a completely different way of thinking about computation, one that lets us tackle challenges we've only ever dreamed of solving.
All right, so here's the plan for our journey today. First, we're going to unpack why quantum AI is such a monumental leap forward. Then, we'll take a peek under the hood at the quantum engine to see how this stuff actually works. After that, we'll explore how it's already starting to shake things up in the real world, and of course, talk about the big challenges we still need to overcome. And finally, we'll look ahead and see what the road to the future looks like for this incredible tech.
Let's dive right in. You see, the real magic here isn't just about speed. It's about being able to handle problems with a truly mind-boggling number of possibilities. Imagine this. You're trying to find the single best route for a delivery truck with 1,000 stops. A normal computer would literally have to try every single combination one by one, and it would be stuck forever. A quantum computer, on the other hand, is built to explore all of those possibilities at once, to zero in on the perfect answer. So how on earth does it do that? Well, to get a handle on quantum AI, we have to dip our toes into the weird and wonderful world of quantum mechanics. It's a place where the normal rules of our everyday reality just don't apply, and where computers can pull off some truly unbelievable feats. So at the very heart of every computer you've ever used is the bit. It's just a simple switch, right? It's either on or it's off, a 1 or a 0. That's it. But quantum computers have something way more powerful, the qubit. A qubit can be a 0, it can be a 1, or, and this is the absolute game changer, it can be both at the exact same time. And this is where things start to get really, really interesting. This whole both at the same time idea has a name, superposition. The best way to think about it is like a spinning coin. While it's in the air, it's not heads and it's not tails. It's this blurry mix of both possibilities. It's only when you measure it, when the coin lands, that it settles on one state. Now, when you start linking qubits together, this power just explodes. With n qubits, you can explore 2 to the power of n states all at once. It creates this massive parallel workspace that classical computers just can't touch. And if you thought that was weird, hold on. It gets even stranger. Einstein himself called this next part spooky action at a distance. It's a phenomenon called entanglement, and it's where 2 qubits become so deeply linked that they're essentially one system. Their fates are intertwined. If you measure one, you instantly know the state of the other, even if they're on opposite sides of the universe. It's this spooky connection that's a key ingredient for modeling really complex systems with QAI. So we've got these incredible, almost magical quantum properties. But how do we actually harness them to build a totally new kind of AI? Let's take a look at how these wild ideas from physics get translated into powerful tools for machine learning. Okay, one of the coolest techniques is something called the quantum kernel trick. Picture this. You've got a bunch of red dots and blue dots all mixed up on a flat sheet of paper. There's no way to draw a single straight line to separate them. But what if you could just lift all the red dots up into the air? Suddenly, it's super easy to slide a new sheet of paper right between the red dots and the blue dots. That's basically what a quantum computer does. It takes messy, tangled data and maps it into a much higher dimension, where suddenly the patterns become crystal clear. And then you have quantum neural networks. You can think of these as the super-powered cousins of the AI models we use every day. By leveraging quantum effects like superposition, these networks can spot patterns in data that are completely invisible to even our best classical computers. They can learn from incredibly complex, noisy information and make predictions with an accuracy we've never seen before. Okay, this is where it gets really exciting. Let's move away from the theory and talk about practice. How is this technology actually going to rewrite our industrial future, not just someday, but starting today and into the coming years? I mean, just look at the potential here. In finance, it could sift through millions of investment options in real time to build the perfect portfolio.
For medicine, it could simulate how new drug molecules will behave with pinpoint accuracy, helping us find cures for diseases faster than ever. In logistics, it can solve those nightmare routing problems for delivery fleets and supply chains. And for our planet, it could help us build way, way better climate models to actually fight climate change effectively. The impact is just enormous.
And listen, this isn't just a far-off dream. This is already happening. In a really important trial, HSBC and IBM used a quantum system for predicting corporate bond trades, and the result? They saw a 34% improvement over the standard classical methods. That is a real tangible advantage, happening right now using the early-stage hardware we have today. But as amazing as that 34% is, it also gives us a hint about the challenges ahead. To get from these early wins to world-changing breakthroughs, we have to be realistic. The road to powerful, widespread quantum AI isn't going to be easy. There are some pretty major scientific and engineering hurdles that we still have to clear.
So there are really three big obstacles. First, we're currently in what's called the NISQ era, which stands for Noisy Intermediate Scale. Basically, it means today's machines are prone to errors and can only handle fairly simple problems. Second, the qubits themselves are unbelievably fragile. The slightest vibration or change in temperature, what scientists call noise, can completely throw off a calculation. And finally, we have to get much better at correcting these errors. Right now, it takes thousands of these fragile physical qubits just to create a single, stable, usable one.
Now, despite those massive challenges, the road ahead is actually being mapped out pretty clearly by the big players in the field. So let's wrap up by taking a look into that quantum future and the timeline everyone's working towards.
Here's the game plan, more or less. For the next 5 years or so, we're going to see more of these experiments and small-scale wins on very specific problems. Then, in the 5 to 10-year range, we expect to see the very first quantum computers that are truly fault-tolerant and can solve some real-world problems better than any classical machine. And then, the big prize. By the 2030s, the goal is to have large-scale, fully error-corrected quantum computers ready to tackle humanity's biggest challenges.
So that brings us to one last really big thought. As this incredible technology grows up, and we move from just solving impossible problems to completely redefining what's even possible, what should we do first? What is the #1 global challenge, whether it's curing disease, fixing the climate, ending poverty, that we should aim this unbelievable new power at? It's a question we're all going to have to answer, probably sooner than we think.